For executive summary, we would like to allocate the water in a smarter way, detect water leakage, and consume waste disposal to generate electricity. For this project, we estimate to be complete within 24 months. Water pollution issue caused by industry has been the main factor in water scarcity. Based on the United Nations World Water Development Report, 6 billion people will suffer from clean water scarcity by 2050. Our solution, which is an intelligent water system with integrated electricity generation and leak detection features, is proposed to solve this issue. This is the organization of our H2O company.
So for project scope, obviously we are trying to address the issue of distribution of clean water, need for effective water distribution, and increased demand for sustainability. And we want to do this to provide a sustainable and self-sufficient solution based on SWOT and best analysis on our. So these are the problems in why we decided to do this project, and also the deliverables that we would have for this project.
For technical requirement, a microprocessor connector pump activates automatically to pump water into the tank when water is insufficient, that monitored by water level sensor. A solenoid valve will open to allow water to flow to the desired location when water is needed. Our water leakage system uses flow sensor to count pulses and compare them to the normal water flow threshold. If the sensor output differs from the threshold value, there may be a leakage at the location. All flow sensor data is compared in the microprocessor and saved in a database using the embedded transceiver to acquire, process, and manage the data. For the electricity generation subsystem, we utilize microbiofuel cell with selected microbes that consume chemical waste in the surrounding fluid to generate electricity at downstream of the system through biochemical process. To monitor the system and access data on site, we have developed a Java-based phone application as server-client interaction model.
Based on the STAR, million liters of water leaking out of the pipe every day in Malaysia. However, existing water management systems do not provide smart distribution and real-time leakage monitoring. Our target customer is Facilities Management Department and regulatory agencies such as PAN.
So for resource and finances, the whole project will cost around 150,000 from research and development until marketing and distribution. And we are expected to complete this project within 24 months, which there are 4 phases and each phase will take 6 months.
This is our WPS. You can see our initiation step is forming project team, define project goals and valuation. After that, we plan our project risk, schedule and tasks. We also identify the project requirement and budget of our system. The next step is design the system with installing the sensor and deploy communication network. After that, we keep testing our system and collect data, and the last step is project closure. And this figure is our schedule of projects. From the schedule of projects, we make our Gantt chart. The main 4 steps in our projects are project initiation, design and development, testing and improvement, and production and distribution. And this part is the monitoring stage of our system.
In this project, it might involve a lot of processes such as filtering, detection, automation, and execution. Therefore, we need to identify and do risk assessment and mitigation plan. In this project, we have used a table to identify potential failure or risk in the system. The S refers to severity, O refers to occurrence, and D means detection. We have identified a lot of failures such as power supply disruption, cybersecurity threats, and we identify the potential effects and the potential costs. Therefore, we can collaborate using SOT and risk priority number, and we can recommend some actions to mitigate the risk. The higher the risk priority number means that we need to solve the issue as far as possible to mitigate the risk.
So for expected impacts and benefits, obviously would have a direct environmental impact by lowering water contamination and enhancing water quality, and also the social impact in increasing public knowledge of the importance of clean water. Obviously for benefits is to continue sustainability. In hopes of with this project, there are more and more projects which would able to be funded to improve sustainability and environmental health.
Next, we'll discuss about intellectual property. Intellectual property is owned by the organization that developed the system. It can be done through branding and images. Therefore, we can establish a strong brand identified through trademarks or logo. The ways to protect intellectual property is through implementing monitoring mechanisms to detect infringement or unauthorized use of project's IP. We can also protect the project's IP by confidential agreement and non-disclosure agreement, which is NDAs. Lastly, we should regularly review patents applications, monitor competitive developments, and consider filing additional patents.
Lastly is approval and customer review, and the stakeholders must expect that this project aims to optimize water distribution, detect water leakages, generate electricity, and filter pollutants. Next is risk, and the stakeholders must also understand that this project comes with risks such as technical challenges, performance limitations, and limitation of liability. Third is disclaimer, and all stakeholders must understand that this project's success are subject to factors beyond our control, and as a result, no guarantees can be made regarding the final timeline or budget. And lastly is the claims, and all stakeholders must acknowledge that any claims to this project should be reported so that it may be solved in a timely and fair manner.